Hello, everyone, and thank you to be here with me today at Ruby Day 2024. My name is Emiliano Della Casa, and as Monica said, today we're going to see how to use Ruby, our favorite language, on an AWS Lambda. First, well, nobody cares, but a few words about myself. My name is Emiliano. I graduated in software engineering in 2005. I co-founded 2 startups. I have worked for 12 years as an independent consultant. And I've like almost 20 years of experience in Ruby projects and Ruby on Rails framework. I'm also the maintainer of Ruby Asterisk on GitHub. That is a library to interact with Asterisk PBX and using Ruby. And I've also contributed to some other gems. Now, I guess you all know there has been a lot of backslash recently in our industry against cloud providers and cloud computing in general, especially since 37 Signals, that, as you all know, is the company behind Basecamp and the company which created and actively maintains Ruby on Rails, since they decided to quit AWS and move everything of their infrastructure to a private cloud. Actually, it's quite a success story because in just a few months, they were able to move almost everything from AWS. I say almost because I think right now just the file tier still resides on S3 service. Also, I think you all know DHH is a strong supporter of monolith architecture. Well, actually, DHH has a strong opinion about everything in life. And, but specifically in the monolith architecture, that is, when all your code resides in a single application or in a single repo, against a more hybrid approach, a more, let's say, Netflix approach, where everything is modularized and in microservices, how they called. I guess I understand DHH point of view. Still, I think there is still space in our little niche of Ruby on Rails programmers to explore other approaches, like the hybrid one. And as always, if you ask me which is the best approach, I would say it depends. Now, if you have been living in a cave recently, I'm going to explain to you what AWS is. AWS stands for Amazon Web Services. It's the main and only, I would say, cloud service provider for Amazon Marketplace. No need to introduction here. Actually, is the biggest contributor of the Amazon global revenue with 16% of total revenue. Also, is the main service provider in the market with a 32% of market share. Sorry, Ricardo, it's the truth. And it offers more than 200 services to the customers. He has 26 geographic zones around the world with 84 availability zones to provide fault tolerance and low latency performances. And counting, because they are adding more and more geographic zones and availability zones. Okay, now let's delve a bit in what AWS Lambda is. Okay, it's not a Ruby Lambda, and this is for sure. What is an AWS Lambda? AWS Lambda can be defined as a serverless computing service, or FaaS, function as a service. It was announced the first time 2014 at the reInvent conference, and since then it has been considered as one of the biggest improvements in this industry. It's event-driven, and it's fully integrated with almost every service that AWS provides. What does it mean, event-driven? Means you take a service from AWS, and based on an event on that service, you trigger a Lambda. For example, you receive an FTP file in transfer family, you can trigger a Lambda. You create a file on S3, you can trigger a Lambda. Or you can just call as a URL, and the Lambda is triggered. It's really interesting because it supports the most used programming languages out there: Java, .NET, Python, and of course Ruby, and in different versions. For example, for Ruby, you can find version 2.7, 3.2, 3.3, and so on. What's the business model? The business model is pay-per-use, meaning you pay for every millisecond that your code run. And for the memory that your function is using. For example, for the first billion of requests per month, you pay 0.000016667 USD per gigabyte second. Now, let's take a look. What is the life cycle of AWS Lambda? When you receive an event trigger, at first, your code is downloaded, okay? And a new execution environment is created. Those two blue blocks here. Then, the executing initialization code of your function, and then, finally, your real code is executed. So what's the difference between blue code and yellow code? The blue code is executed only when your instance is created the first time. And the yellow code, of course, is the request. Every subsequent request that arrives just executed the yellow one. It is also really interesting that AWS just charges you for the yellow part and not for the blue part. The blue part is free, let's say. How long does the instance last? Well, actually, it depends. Every time you upload a new version of your code, the instance is declared erased, and a new instance is created. So, for example, here, you receive a request, your instance is created, executed, then you upload a new version, and the instance is created again. You understand that the cold start phase that creates a pre-warmed, as they say, a pre-warmed environment could be both an advantage and a drawback. Why an advantage? I said it's free, meaning that every initialization code, heavy duty, could be put in that phase. It's free, you're not paying for it. For example, initialization of cryptographic libraries. That could be a nice example. But, of course, it can be a drawback, especially if you need a fast reaction to triggers. This is where provision and concurrency comes to help. So you can ask AWS to keep a number of instances ready and pre-warmed for you, of course, for an extra cost. For example, we can ask to keep 6 instances pre-warmed, they are initialized, then they are ready in the green area, ready to receive requests, and when a request arrives, first come, first served for the first 3 here. That means that if you receive 6 requests at the exactly same time, they get served and executed in the exact same time. So, for example, if you just have 2 and 6 requests in a staggered arrival, the first is initialized and receives the first request. Then you would receive the second one, but the first is busy. So the second one is created and executed, and so on. So they're queued and split between the two instances accordingly. What happens if we have just one? Simple. It's the 6 requests are queued and executed one after one. Okay, and if you see, the cold start duration just happens at the first. Actually, it's almost true because AWS from time to time, based on their algorithm, from time to time, erased working instances, even if you didn't upload a new function code. But it's up to them. So you may ask, what are the advantages of FaaS? Well, for us developers, I would say that you can focus on code and not on infrastructure. So actually, we can focus on what we like more, you know? And we can take advantage to the inherent scalability of Lambda. On the other hand, for managers, what is really interesting is the reduced time to market, meaning the time from writing code to code that goes live into production is reduced. And of course, it's crucial for them. And the flexible cost. No use of the function, no pay. You pay just for the execution time of your code. Okay, so let's start seeing some Ruby code. And as we said, let's go back to the basics. There is nothing more basic than this one. This is a simple hello world file, example. We create a lambda underscore function RB file with a simple function in it, no object, just a function, lambda handler, with 2 input parameters that are predefined by AWS, event and context. Event contains all the information regarding this particular event received at this particular moment. Context is an object, is a meta object, let's say, about the function itself. For example, we can ask in the context how many milliseconds are missing for timeout and behave accordingly. We love Ruby, we know how does it work, how ChatGPT, the weirdest part is returning the last directive is the return. Okay, so this function just returns hello world. Okay, that was quite simple. Let's take a look at a more complex example. Not that much. Imagine your manager comes to you and say, okay, I need a software component to send notifications to our user using a simple HTTP request. This component would be called by one of the many softwares of our company, written in Python, Ruby, Ruby on Rails, Sinatra, and so on. And so we need to support all these different services. So your developer say, okay, let's go with the microservice approach. Why? Because first of all, you want to keep it framework and language agnostic, so you can call it wherever you want. And you want to take advantage of the scalability and of the centralized architecture. At first, you're going to use Twilio for sending an SMS notification. So this is a simple file using the net HTTP library built in Ruby. You create the URI, you take the from to body input parameters from the event body field, sender, receiver, and text. We create a post request. We add a basic authentication. Please don't commit credentials in your code base. I did it just so you understand, but don't do it, please. Don't try this at home. We start the request. we pass the response body, and we take the SID field that is the unique identifier of our message. Okay, cool. This is working on my local machine. We need to deploy to the cloud, right? Great. Let's zip the directory containing your code. Just the Lambda handler RB will be considered. Everything else is optional. Actually, there is a limit of 250 megabytes to AWS. So you zip directory, you go to AWS page, Lambda page function, create function. This form appears. This is a wizard, pretty simple. This is just basic. Then when the function will be created, you are going to have some more settings to play with, but let's keep it simple right now. So you specify the name of the function, the runtime that you want to use, the architecture. You can choose between x86 and ARM64, permissions, and so on. So we proceed. Then we upload the zip file we just created to AWS. We get a URL to send our HTTP request. And this is an example of the request, specifying the input parameters. You understand this is not really a process you can do in your everyday life, right? We want to automate, because I guess everything agrees that every manual process can lead to errors out of abstraction. How do we automate this? We can use it, the serverless framework, that is a library written in JS. Unfortunately, as far as I know, there is nothing for Ruby, but this is written in JS. It uses YAML-based configuration files, is declarative. What is more interesting is extensible with plugins. So there is a long list of plugins we can use to automate and include every possible service. It's really simple to install and use. Just install with npm, initialize your application with SLS, and with SLS deploy, you deploy to the cloud. And this is an example of a file. The service field is the name of your application. In this case, it's HTTP to SMS. Then the framework version number 3. Last one is number 4, but we are using the 3 right now. Then there is the provider section with those settings that are valid for all your functions. So for example, the name of the provider, AWS, the region where you are going to store and execute your code. For example, the timeout of your function, the size of the memory that your function will use, the architecture, and so on. And then a function section with a list of all the lambdas that you're going to use. The key of a YAML is the name of your function. Handler states which is the Ruby file that you're going to use. Ephemeral storage size is the size of, let's say, the drive of your function. This memory is erased every time a new instance is created, so don't rely on this, just for temporary files. And then we can set environmental variables. For example, in this case, to enable widget, the new widget, you just set Ruby igit enable 1, and this enabled by default. Then we specify that the event that triggered the function is an HTTP request with path send, method post, and enabling CORS. Now your manager comes to you and says, hey, I heard about this Faraday jam. It's pretty cool. Performance are okay. Let's try this. And you say, okay. She pays, right? So, okay, let's pay. Let's do it. We archive Faraday, and this is just a simple refactoring of our function. I won't go into detail. It's just the same. It's doing just the same. But we included a new jam, right? We need somehow to manage all dependencies. So we create, as good Rubists, We create a gem file, we specify source, the Ruby version, and we add that we want gem Faraday at version 2.9. Fine. Bundle install, all the dependencies are taken care of, and we're fine. That's working. Unfortunately, on cloud, this is not working. Could not find Faraday 2.9.0 in any of the source. Why is this? Well, we couldn't expect any different. AWS simply cannot store any single gem or library out there. It's impossible. So we need to find a way to tell AWS to use a specific, the specific gem we need for our code. And this is the reason why in 2018 they introduced AWS Lambda layers. What is a layer? A layer is a collection of gem and libraries used by your code. You can have up to 5 layers linked to a single function, but you can use a single layer for all the functions you want. You just need to link it. And what is a layer? A layer is simply a directory, a simple directory with a specific structure. Like, for example, in Ruby, is Ruby gems 3.3.0, and that's it. We store the gem here, zip it, upload to AWS, too complicated. Let's use a plugin, serverless Ruby layer plugin for serverless. We install it. We include it in the plugins over here. And what does it do? Every time we deploy our code to AWS, this plugin reads the gem file and do all the manual process for us. Install the bundle install in a file, zip, send, and link. Magical. Now, there is a third way to create and manage Lambdas on AWS, and is using containers and Docker files. Well, I won't explain what Docker is because I'm not the right person to do it, and there isn't time enough today. Let's say for today that a Docker file is just like a make file to create virtual environments. A Docker expert will beat the hell out of me today, but sorry, you will excuse me. Just keep with the definition. We start from a basic image taken for AWS ECR, that is a service is a repository for containers. We copy the gem file to a specific directory, run gem install bundler, copy our file, and this is the entry point. We specify the name of the file and the name of the function containing it. And it's easy to manage it using serverless. We just need to add an ECR section with all the information, with the path to the Docker file, and link it in our function. And serverless will take care of build the image, send to AWS, and link to your function. What are the pros and cons of using Docker? Well, since under the hood, when you send a simple Ruby file, this is what AWS do. It copies your file, creates a container, and executes it. So you can replicate that behavior on your local machine. You build with Docker, run it, and invoke the function using this URL on your local machine. So you can replicate the behavior of AWS on your machine. So there's no need anymore to test your code on cloud. And there is no need of an external plugin anymore because everything is taken care by the Docker file. Of course, there is a slower deploy time because every time you deploy your image, the image has to be built, sent, and so on. So you have to take this into account. Now, if you're truly a Rubyist, we are missing a part here, right? Automated testing. What if you have to automate it, test your code always? So I wanted to add rspec to our gem file to include test. In the group development test, we need to modify the Docker file because, of course, I don't want development libraries on production. So we set bundle to exclude development and test groups, and everything is just the same. And at last, we create a spec directory with the Lambda function spec in it, and it's simply, we give valid inputs to our function and expect a valid output. Of course, since you don't want to receive an SMS every time you run your test suite, we are mocking Faraday connection to receive a post request and with this response. So let's make a small recap of what we learned today. Today, we learned what an FaaS is, a function as a service is. We learned what is the basic Lambda structure for Ruby. We learned how to deploy automatically without effort using serverless framework. We saw how to send a Lambda with code or with a Docker image, and we saw how to test it with rspec. Thank you very much. If you have any question, please.
Thank you so much.
You're welcome.
I wish I had this talk last year.
I'm 1 year late.
Yeah, no, I was trying to figure out, I was like, I've never done it. I had some free time. I was like, okay, let's dig into this. But this is so much better than doing it on my own. We have a few minutes before our next speaker. Are there any questions that you might want to ask Emiliano? I know it's awkward silence, but that's normal. Božidar.
I'm curious, Emiliano, how far would you take this approach? How complicated applications would you try to run? So, Emiliano, I have the following question. How far do you think this approach can be taken? Because, okay. I'm wondering what are the complexity boundaries? Obviously, we cannot run a full-fledged web application there.
Well, I guess there are limits you have to respect. For example, if you ask me, okay, should I refactor my Ruby on Rails application and every single controller action goes into microservice? I will say no. Would you ask me, okay, would you chain 5 or 10 lambdas one after another? No, I wouldn't do it. I think, as I said, there is the all monolithic approach, the HH favorite, or the full hybrid all microservice approach. I think that to be wise is to be in the middle and understand which parts you can take advantage of the microservice approach, the more scalable, the one that can be used without prediction. You don't know when or how you're going to receive. When you have, for example, stable requests, I would go with the monolithic one, okay? Hope I answered your question.
This makes sense. And if I may ask a short follow-up, and how would you compare this to doing the microservices on something like Kubernetes, which is another popular approach?
Yeah, I think there are competitors. I mean, for example, you could also use Fargate or Kubernetes or KQS. Yes, I think it's KQS, the service for AWS. Of course, those are all competitors. And I guess Kubernetes is much more complicated when it comes to orchestration. AWS Lambda is just send a function and you're done. So if you want to pursue a simple approach, I would go with AWS. If you want to try, if you want to play with it. Always being ready to change and go to Fargate to Kubernetes or to an old simple bare metal server if you see that you're falling behind, you know?
Thank you very much.
You're welcome.
Thank you. More questions? No, thanks.
Have you ever tried Jets, and how do you compare this approach with Ruby on Jets if you ever tried that?
Yeah, I tried using it. Actually, it's quite interesting. Still, what concerns me more about Jets, well, maybe time has passed, so maybe things have changed. But Jets is really AWS focused, right? You can just deploy to AWS. Another advantage of the Docker approach I showed just a few minutes ago is that you could take this Docker container and change a little, of course, and push it to Google to make Ricardo happy, or to Azure, and so on. With Jets, you're just bound to AWS. What would I prefer, sincerely, is I would like to find a gem that takes a Rails application and push it to AWS, Azure, and so on. I really would like to be able to do it. Maybe once, sometimes I will try, but this, I think, it would be much